So now we're ready for section 10.5 in geometry, and we're going to look at volume. And at the end, we'll look at some, what we call it, surface area. So between these two, we'll get the ability to figure out how much space is in a three-dimensional object, and then also how much we might need to cover that three-dimensional object, like a box, how much surface area or materials we need. And that will really complete the mathematics of geometric shapes. And for three-dimensional world, for two-dimensional world, and I guess sometimes the one-dimensional world that we need when we're running lengths of things. So here we are, Geometry, Chapter 10. We're going to look at volume and surface area. So for volume, much like we did with area, for two dimensions, notice a two-dimensional, remember we just kind of said, okay, we've got this rectangle, and if it's a 3x4, we could just count how many squares, 4 this way, 3 this way, and we counted on a two-dimensional, 3 times 4 would give us 12 square units. Okay. With volume, we've got an additional dimension. So we've also now got height. So as we see the shapes over here, as we stack them up, we now have a cubic unit, not just a square unit, a cubic unit, because we're taking up space, 3 dimensions. So we get 3 dimensions multiplied together. We get a length, a width, and a height, multiplying all those together. So over here, we get 3 times 3 times 2. So that's 9 times 2. If we were to count it, we would count actually 18 cubes there. We'll just do it with units cubed. Okay, square is going to be again, not really a square, but a cube has the same length on all sides and the height, and a rectangular solid is a length and a width and a height, and all 3 measurements can be different. 2 could be the same and 1 could be different. That would still be a rectangular solid. But if all 3 are the same, we call that a cube. So the cube is a special case. Okay, and that'll be the basis for pretty much all the formulas we're going to use from here. However, we'll throw a few more in here. Okay, so first of all, we're going to do a volume problem, and we want to make a new swimming pool. So we need to dig it. We need a hole that is 90 feet long. That's a nice, this must be like Olympic-sized swimming pool. 60 feet wide is huge, and 6 feet deep. That's about to the top of a little bit over my head, right? So you're going to have a truck that can carry 10 cubic yards. Now notice the difference in units that are being used, feet and yards. So if we're going to figure out how much it will cost to have the dirt hauled away, we've got to convert all of our measurements into yards, and then we'll be able to multiply. We'll divide to figure out how many loads we need, right? So 10 cubic yards per load. So how many cubic yards we have divided by 10 cubic yards, that's how many loads, and then take the loads times 35, and we'll have what we need. So convert feet to yards. So here's our basic from the unit we covered before. Since we want to get the feet turned into yards, we divide out the feet. So there's 3 feet in 1 yard. 90 divided by 3, we're going to have 30 yards for the length. We do the same type of conversion for each of it for the 60 feet and the 6 feet. Divide each of them by 3. So we'll take a shortcut here. 60 feet is 20 yards. 60 divided by 3 is 20. 6 divided by 3 is 2. So we now have the volume. We can calculate the volume. All right, 30 yards by 20 yards by 2 yards. Multiply all of this together, 1,200 yards of dirt to get out of our backyard. How many trucks is it going to take? Well, remember, it was 10 cubic yards per truck. reminder here, 10 cubic yards. Come on. So here's our calculation, 1,200 divided by 10 yards per trip. And again, this one will flip like you see down here when you're multiplying by a fraction, flip and multiply. The yards are going to cancel out. 1,200 divided by 10 gives us 120 trips. So each trip, remember, is going to cost $35. So now we multiply, if we don't get too dizzy, the trips will cancel. 120 times 35 is going to give us $4,200 just to get the dirt taken away. That didn't even count for the guys that needed to dig it. And I saw this done. They're very skilled workers. And in Arizona, you don't want to try to dig your own pool. It's this soil is hard. I try to even plant my own tree here because I'm from Oregon. We did that all the time. You need a jackhammer even to plant a tree. So anyway, money well spent. So it's going to cost you $4,200 just to have the dirt hauled away. Now let's again, this unit is not about building swimming pools, but about finding volume. So we've got a Transamerica Tower in San Francisco, very iconic. It's a pyramid with a square base, and they can measure that it's 256 meters tall, and on the base it's 52 meters long. So 52 here, and it's a square base, 52. The height is 256. So to get the volume, how much the building will be able to hold, we take 1/3 times the base area, which is going to be 52 times 52, right? Side by side, times the height. So that's our formula for whenever we're going to do a pyramid, is we take the area of the base, 52 times 256. Now, if it went straight up, we just do the 256, but because it's a pyramid, that's where that 1/3 comes in. Why 1/3? It just is. You could go into the mathematics. There is a way that they derive it. It's more than I want to deal with. I tried to teach three-dimensional geometry when I was in Kazakhstan. The Russians are really masters of three-dimensional geometry. And all the books are in Russian, so you've got to first translate it, and then you got to figure it out. I'd like to just say, take their word for it. Somebody did the heavy lifting, and it's just going to be this formula. All the formulas will be provided to you. So we just click here. We'll even let them do the calculations. So 52 times 52, that's the area of the base. Remember, that's just a two-dimensional. That's why it's squared. And so all we have left to do is to take this number, the 2704, we need to multiply it by 1/3, and then we also need to multiply it by the height. And that now gives us units that are cubed, so we know we have 3 dimensions. That's a lot of space, cubic space. And a cubic meter is pretty big. It's, well, you can't see it but my hands are way out there. It's like telling a fish story, right? It's huge. Cubic meters. Okay, and that's what you're going to see is really why we're having you do this, is learning how to use mathematical formulas, plugging in things, figuring out what the formulas stand for, putting the numbers in place, following the directions. That in this case it's all multiplication, and it gives us the volume. Right circular cylinders is going to be very similar. Notice you've got pi r squared, so that's the area of a circle. So that's either the base or the top. And then you're going to multiply by the height. So kind of you've got all these layers that are going down. So if we're given information like this, that we've got a diameter of 20 yards, remember what we need here for the formula, what we need is we need the radius. So we got to divide the diameter by 2. We're going to have 10 yards. Then we're going to take that 10 yards, that's our radius, we're going to plug it in for the r. So we're going to have pi times 10 squared times the height of 9, right? Ten squared is 100, times 9, that's going to be 900 pi. A lot of times we can just leave that answer as is, but we can also multiply it out to get it that it's actually 2,827 yards approximately, because remember pi is not is a number that is non-repeating, goes on forever. So the best we can do is approximate. We get close enough. Okay. So again, just using the formula, plug in the values, and then be careful. Watch what you're given. We were given the diameter. The formula needs the radius, so we needed to get half of that. This is an interesting problem. We're going to compare. We're actually going to get two volumes. So the volume of a cone. Again, notice it's a little different, but this is the formula we've gotten. And again, why the 1/3? Just because somebody, again, figured it out, did all the heavy lifting and all the work on that. But it's 1/3 pi r squared, which is remember, pi r squared is the circular base times the height. And this 1/3 just tells us we don't have we had a cylinder, we wouldn't have that 1/3, but this is only 1/3 of what a cylinder would be. A sphere, again, I don't know where the 4/3 really comes from. It's in deriving the formula, which is a bit of work, and that's beyond what we're doing for this course. We're just saying, if I gave you this formula, could you use it? So if you need the volume of a sphere, you'll just say, give me the formula, and here it is. It's r cubed times pi times 4/3, and we will give you those formulas. So now this is the interesting problem we're going to take a look at. We've got an ice cream cone. So the cone is 5 inches tall, and it has a radius of 1 inch. So we've got this 5 inches deep or tall, radius of 1 inch. So we can put a 1 inch scoop of ice cream, spherical scoop, with a 1 inch radius. Okay, because this top also has a 1 inch radius, so it should fit right down in there. Now, I think actually it would fit deeper down in there, but so this drawing's really not to scale, but what do we need to do? Well, let's figure out what's the volume here and what's the volume of the cone itself, and which one's bigger. Will the cone be able to hold all this volume if it melts down in there? So what's the volume of the cone? Well, again, remember that formula. It was, and again, you don't have to memorize it. It'll show up here in a minute, but I think if I get it right, what was it? 1/3 pi r squared times the height. So it should be, let's see, there we go. It's just coming, 1/3 pi r squared times the height. The radius is 1. That's what they gave us the radius, not the diameter, so we use that. And we know the height is 5, so we multiply this. 5 times 1 is 5. 5 times pi is 5 pi, divided by 3. And if you plug this in your calculator, you get approximately 5 inches. I think what they did is 3.14 and 3 is kind of close, so they said, hey, it's about 5 inches. It's probably a little bit more. If you did the exact calculation, 5 point something, but we know the cone has a 5 inch or maybe a little bit more. How about the sphere? Come on. I gotta get the pen away from there, I guess. So 4/3 pi r squared, or pi r cubed. 1 cubed is 3. Go through, do the math. 4/3 pi is about, and again, they just did this canceling again, say that's going to be about 4 inches. So 4 inches is less than 5 inches significantly. There's an extra cubic inch of space in there, so it has room to melt and still be there. My question is there a hole in the bottom? At least mine always seems to be, and it's going to just drain out the bottom anyway. Okay, why don't these math guys ever think of that? Okay, so yes, the ice cream could melt, the cone could help but hold it, but if you've got cones like me, it's going to leak out the bottom. Surface area. This is our last little bit, and this is kind of where the 2 dimensions meets the 3 dimensions. So surface area is a 2-dimensional measurement. It's basically what is the skin around a cube, a rectangular solid, a circular cylinder. So, like this. I'm not advertising for 7-Up, but I do like 7-Up. How much aluminum do we need for a can like this, and then the top is circular. So that's why we might use this, is to figure out how much materials we need to build these sort of things. So again, we're just going to give you the formulas. You're going to apply them. Now, a circular cylinder, remember you need radius, not diameter. Okay, you'll need to have the height. Rectangular solid, you'll need the length and the width and the height. And notice each one of this is length times width. So here's, let's see, where would the length times the width be? There's the width, there's the height. It'd be up here. So it's your top and bottom. So this one here is your length times your width. You got two of them. You got a top and bottom. Length times height is sort of your front and your back. So if you see this one is length times height. And then width times height would be your two ends. So like here in this side, we're going to have the width times the height. And again, we've got two of those sides. So that's where that formula comes from. Multiply and then add the three together. We've got it. A cube, simply each side is s times s. And then if you count them, 1, 2, 3, 4, 5, 6. So there's 6 sides to a cube. And that's how that one is arrived at. We're just going to look at one quick question here. So if we've got a length of 8 yards, a width of 5 yards, a height of 3 yards, what do? Multiply them all together. 5 times 8 times 3, that's 40, times 3, that should be 120. And what do we have? We've got yards cubed. I'll let them do it. Oh, wait. We're not doing volume. Back up, little crow. That's volume, and that's good. But we switch gears, and I'm still on autopilot. Okay, so we're doing surface area. So length times width, so 8 times 5, and we've got 2 of those. And then length times height, that's the front parts, right? Length times height, 2 of those. And we've got the width times the height, which are the in cabinets, like right here. So there's that side and that side. There's our 3 times 5. So do the math. Here we get 40 times 2 is 80. Here we get 24 times 2 is 48. And here we get 15 times 2 is 30. Add them all together. 158 yards squared. So that's how much material we would need to make this box. And that's it. Volume, surface area, and now just start working the homework and go ahead and take a look. We've got the Zoom classes to come to, those kind of things. And yeah, I might work a few of the homework problems to get you started on it. Ask questions, but move forward. Use the formulas, plug them in, and get the values. Thanks.